All right, this video is about identifying if a relationship is proportional or not, and we are going to look at tables, graphs, and equations to determine if they are or are not proportional. The paper I'm using here is an exit ticket that we did in class, and I've already identified which of the relationships are proportional and which ones are not. If you look at this, let's start by talking about this table. We can tell that this table is proportional because if I choose any of the rates in the table and I set them equal to each other, I can always find a giant one to scale up by them. So in this situation, I can scale up by 2. I could also set 1 over 3 equal to 12 over 36. And I would realize that my scale in this situation is 12. And I could do that for every single rate on this table. But to save us time, I'm not going to. So that is one way I can prove it's proportional. Something that's tricky about this table, however, is it doesn't show us the value for 0 leagues. So when it doesn't show us those values, we have to add them. So in this, if I start at 0 leagues, I would also have 0 miles. And the way I could figure that out is by following the pattern that I change by 3 miles for every 1 league. So if I worked backwards here, I would take away 3 miles from 3, and that would bring me back to 0. So this is actually a proportional relationship because we could work and figure out what the value of 0 leagues would be. The other proportional relationship on this handout was this graph right here. And I'm going to zoom in just a little bit so we can look a little bit closer at the numbers. So this was talking about Miguel's savings. And we can prove that it's proportional because if we look right here, we'll notice that it starts at 0. So it starts at 0, 0, meaning that if he has 0 months in the bank, he has $0 worth of savings. And as we increase, when I looked from 0 to 1, I noticed, well, this value is about 15. 2 is now at 30, so we're consistently increasing by about $15 every time we increase one entire month. So because it starts at 0 and has a constant rate of 15, this is also a proportional relationship. Now we're going to look at our first graph that shows that it is not a proportional relationship. And to prove something's not proportional, I only need one piece of information, either that it does not have a constant rate or the fact that it does not start at 0. And when I look at this graph, I can clearly see that the starting point is not at 0. So does not start at 0. And for that one piece of information alone, that proves that this graph right here is not proportional. Because we can notice, well, hey, it's increasing at what looks to be a constant rate, but because it does not start at 0, we can't claim that it's proportional. Our last one we're going to look at is also a not proportional relationship or non-proportional. And we're looking at this equation right here. Well, this equation does show that it's increasing at a constant rate of 12 because anytime I buy a new t-shirt, I'm paying $12 more. But the piece that makes it so it is no longer proportional would be this plus 50. So if I were to actually solve this right here and say that if I bought 0 t-shirts, well, I'd pay $0 in this part, but I also have that extra fee of $50. Excuse me. So because I have this additional fee right here, I wouldn't start at 0, meaning this would not be a proportional relationship. So looking at 4 different situations, we were able to determine if they were proportional or not. If you notice with the proportional relationships, I always gave you two pieces of proof or evidence that they were proportional, their starting point, and if they are increasing at a constant rate. But for the ones that are not proportional, those relationships, I only have to provide one reason why they are not proportional, and that is enough information. All right, thank you for watching.